Hi, good evening, everyone. Welcome to everyone joining us for this evening's Nutshell discussion. If it's your first Nutshell, you're really in for a treat. My name is Kelly Gilbo, and I'm one of the outreach coordinators for the Savannah Institute. Before we get started, I'd like to tell you just a little bit about the Savannah Institute. If it's your first time joining us, or for those listening online, we are a nonprofit organization focused on research and education about agroforestry. This means working with trees that produce crops, which help make farms more profitable, resilient, and healing for the environment. It can take many forms depending on the farm and the goals. A lot of our work is doing research in cooperation with farmers, connecting farmers and scientists at universities and other organizations. We host lots of events at farms, and we have a perennial farm gathering each year. This is coming up in December. Keep an eye out for that, save the date. And this is with an aim of helping farmers share what they're learning with others and more broadly with each other and the community. We develop educational resources, and all of those, of course, can be found on our website, savannahinstitute.org. I'd like to also thank our sponsors, the Hegner Family Foundation and North Central SARE. Without their support, we wouldn't be able to bring you these Nutshell discussions for free. And of course, thank you to all of you for joining us. During this evening's discussion, if you're joining us from a computer, I'll invite you to share your questions and comments as we go in the chat box of the platform. So the little pop-up screen with the free conference call platform has a little chat bubble, and you can click on that and type in your question at any point, and I'll sort of be monitoring those throughout, and you'll have a chance to ask those at the end of our time together. I will have time for an official Q&A session, and at that opportunity, you'll even be able to use your own mic to ask questions. So stay tuned for that. So without further ado, we're honored to welcome our presenter for the evening, Gabriel Pent. Gabriel is the Ruminant Livestock Systems Specialist at Virginia Tech's Southern Piedmont Agricultural Research and Extension Center. The focus of much of his research has been on the impacts of trees on forage characteristics and animal productivity and welfare in silvopasture systems. And I believe that's what he's going to share with us tonight. So we're excited for that, and at that, I will turn it over to Gabriel to get started.
All right, sounds good. Thank you. And thank you to the Savannah Institute for putting this on. Appreciate the ability to talk about some of the work that we've done here in Virginia on silvopasture systems. There may be some parallels between here and the Midwest, which is where the Savannah Institute is located. Probably not exactly the same, so I welcome perspective and discussion about what you think about our work here and how it may relate in a different environment. So I've been now with Virginia Tech for a few years as a graduate student in Blacksburg in Southwest Virginia, and then now as a faculty member at the Southern Piedmont region, which is more south central in the state. Dr. Roy Blazer was a foundational forage scientist in Virginia for some time, and he developed many studies, one of which was this one, which shows generally what happens to livestock here in our state in the summer months, even when forage productivity stays about the same in the summer, which is that dotted line there per animal. Animal productivity really declines, and that's because as animals get heat stressed, they stop eating, and thus they become less productive. And this is pretty common throughout the state, where we see maybe 1 or 2 trees in pasture, very little shade is available to livestock. In many cases, we fence livestock out of waterways to protect water quality, but as a result, animals have less access to shade or water where they're keeping cool. And so the summer slump is quite an issue here in Virginia, and I see silvopasture is providing some opportunity in dealing with those issues. In addition, we rely pretty heavily on a perennial cool season grass called tall fescue. I think you're less reliant on it in your area, but here in Virginia, it makes up the predominant portion of all of our pastures. And it does well in Virginia. That's why we like it. And one of the reasons it does well is because it hosts a fungus in a symbiotic relationship called an endophyte. And this fungus helps the grass persist, and in return, the grass gives the fungus some food and a place to live. The fungus also produces secondary chemicals, some of which are toxic to livestock. The ergot alkaloids are vasoconstrictive, which basically means that the vascular system of livestock is constricted. As you can see in this picture, there's an animal, an X-ray of a cow hoof on the left. That's a normal animal where the vasculature extends all the way to the bottom of the foot. And then in animal grazing, toxic to fescue, the blood vessels end prematurely. And so you can imagine during cold weather, this is a problem and can lead to frostbite of appendages. But also it's an issue in the summer months where an animal's blood flow is impaired, and so they can't efficiently pump blood from deep in their body where it's warm to the outside of their body where they would be able to dissipate heat. And so this has a large exacerbating effect on heat stress in Virginia. We sampled pastures last year, about 21 pastures across Virginia, to get an idea of how many of these pastures are infected. And we found that the vast majority of those samples that we collected were highly infected. So most of the pastures were at least 70% infected or more. And it seems to be that these pastures are becoming more and more infected over time, which makes sense as the endophyte in our area conveys an advantage in terms of survival to the host plant. So this is becoming more and more of an issue and recognized as such. And silvopastures, I think, provide an opportunity to give relief to livestock during the summer months when they're suffering from heat stress because of the presence of trees in pastures. So here's some of the silvopastures that we've studied. These are in Blacksburg, Virginia, Southwest Virginia, near the Virginia Tech campus. And we've compared two different types of silvopasture here. These were planted into pastures about 20, 25 years ago. And the black walnut trees, of course, also produce nuts and valuable timber. These millwood honey locust trees are actually a grafted variety. The millwood variety, they produce extra large pods, and they are thornless. So there's some additional products that they provide. Of course, the management goal of these systems is to maximize the positive interactions between trees, forages, and livestock so that we can optimize productivity or services provided by land. And one of those interactions is the provision of shade to livestock, particularly in the summer months. Some of the early work on silvopasture and animal performance came out of the University of Missouri, the National Center for Agroforestry there. And they looked at black walnut and pine silvopastures, and they had annual forages, in this case ryegrass and cereal rye, planted underneath these trees, and then also in open pasture systems. And they compared forage productivity and animal performance in those two different systems. And so this figure shows the black bars are the deviation of the silvopasture from the control or the open pasture, which is that green line set at 100%. So, for example, the forages in the silvopastures grew about 20% less the same forages in open pasture systems without any trees. There were some slight improvements in forage protein, a little bit less fiber in the silvopasture forages, and subsequently animal performance, in this case cattle, in those silvopastures, they gained the same amount of weight in the silvopastures as they did in the open pasture systems. And so something, perhaps it was improved forage nutrition or animal comfort, was compensating for that reduction in the amount of forage because animals still gained the same. And I think this is significant because it shows that not only are we producing the same animal output on silvopastures, but we're also producing tree products. And so the land productivity of these systems is quite a bit higher. Here's some data from that site in Blacksburg that you saw the pictures of a few slides back. In this case, the black bars represent the black walnut silvopasture, yellow the honey locust system. And again, the researchers at this time saw a little bit less forage underneath the silvopastures compared to the open pasture system, which is that green line. There was very little difference. In this case, these were cool season forages, perennial forages. There's very little difference in forage protein and neutral detergent fiber content, but there was no significant differences in terms of animal, in this case sheep, performance or average daily gains in the black walnut or the honey locust silvopastures compared to the open systems. About 5 years after that study, the trees were thinned. About a third of the remaining trees from that initial study were left. Of course, they were older. This is about, I guess, about 6 years later when we started to work up again. So the trees are larger, but there's a little bit less of them. We did a similar study, and we found that in this case, the forages underneath the black walnut silvopastures were reduced by about 30% relative to forages in open systems. And actually, there was a little bit more forage in the honey locust systems, not much. Again, there was little difference in forage neutral detergent fiber, a little bit of an improvement in terms of forage protein. And yet, even with substantially less forage in the black walnut systems, there was no difference in animal productivity between any of these systems. And so it's clear from these data and the data that we've seen before in Virginia and also in Missouri that something besides just forage characteristics is driving animal performance. And of course, our hypothesis would be that improvements to animal comfort can play a large effect in compensating for those reductions in forages that we see underneath trees. Here's a map of Virginia just to give you an idea of what all I'm talking about. Blacksburg is where this site was that we've done the sheep work with. It's the orange dot there. It's in kind of southwest Virginia. It's pretty rolling topography there. It's a hill site where the silvopastures are planted. It's relatively cool. In the summer times, it rarely gets above 90 degrees Fahrenheit, or at least during our study period. And at some point, it would fall below 50 degrees Fahrenheit in the summertime. And so there was some substantial cooling effects in the evening. Here's an aerial view of what that study site looks like across the hill. It was 3 treatments, of course, replicated 3 times. And throughout this presentation, I'll use the same color scheme so that you can follow. The black walnut silvopasture is represented by the black color. Yellow represents the honey locust silvopasture, and green, the open pasture system. We did this study again for 3 different summers, about 12 weeks out of each summer, using different types of lambs, and we did some statistics. And we weighed the animals every 4 weeks to measure their performance. We took small temperature loggers and we put them inside of blank seeders. These are devices typically used to synchronize estrus in the flock. And so we used blank seeders. We put these little temperature loggers in, and we inserted them into sheep so that we could actually collect their core body temperature every 10 minutes without having to disturb and thereby elevate their body temperatures. We also used time-lapse cameras to take pictures of the lambs in each system every minute for 1 day of each week. And then we spray painted the sheep so that we could go back later and determine not only their utilization of the shade in these silvopasture systems, but also their different activity patterns. I like to tell people, kind of joke, that it was significant how much more we enjoyed working in the shade of these silvopastures compared to open pasture systems. But I do think that also is a very substantial benefit of these silvopastures, is the improvements in human and farmer welfare as well in working in these types of systems. Here is the average daily gains of the lambs over those 3 summers in our pastures. Again, black represents the black walnut silvopasture, yellow the honey locust systems, and green is the open pasture, the control without any trees. Throughout all 3 years, the lambs in the silvopastures did as well or better than lambs in the open pasture systems. However, we did stock according to the amount of forage available in those pastures. So in the case of the black walnut systems, we actually stocked those with a little less sheep than the other treatments. So it would be more appropriate to look at total animal output per system. So when we do that, we found that over those 3 summers, there was no difference in the animal output between the silvopastures and the open pasture systems. So again, anything that these trees produce, whether timber, nuts, or pods, or firewood, represents the net productivity of those systems over open pastures, at least during the summer months or the growing season. So what was going on? If there was so much less forage in the black walnut silvopasture, what was compensating for that, such that the animals gained the same amount of weight in these types of systems? Well, we know that animals like shade. So this figure illustrates that, which it shows the time budgets of the lambs in minutes per day along the x-axis. The animals in the black walnut and honey locust systems, shown by the black and yellow dots, respectively, spent over 90% of the day in the shade. So as that shade moved across the slope, as the sun moved, the sheep would get up and they would move with it, following that shade, tracking that shade very closely. So the animals definitely use the shade. The lambs in the black walnut systems spend a little bit more time grazing, though not significantly. I'll get back to that later. But the most important thing was that the animals in the silvopasture spent more time lying down. The animals in the open system, shown there by those green dots, spend about 2 hours longer each day just standing up. And this represents some important things. First, it takes more energy, about 15% more energy, to stand up than it does to lie down. And so in terms, as far as the producer is concerned, that is energy that is lost from animal productivity. And then also, the time that an animal spends lying down is a traditional metric of how comfortable an animal is during a period of potential heat stress. And so from these data, we can be very confident that the animals in the silvopastures were more comfortable than animals in the open pasture systems. These sets of figures shows grazing activity, the proportion of animals grazing at any moment in time, from all the data that we compiled from the time-lapse imagery in 2015 on the left and 2016 on the right. And I just want to illustrate a point here that in 2015, you'll notice the animals in the silvopastures grazed more evenly throughout the day, whereas the animals in the open systems were more crepuscular in their behavior. They grazed more in the morning hours and then were largely inactive during the afternoon, and then started grazing again in the evening. In 2016, that distinction largely blurred. Animal grazing behavior patterns were pretty similar across the 3 treatments, and this may be perhaps we switched to a hair-sheep cross in the final year, which are typically more resilient in terms of heat stress than wool sheep breeds. And so that may have blurred the distinction in grazing behavior, but certainly in 2015 there was a large difference in the behavior of animals. This figure shows the advantage that trees provide in terms of keeping animals cool. Vaginal temperature is defined there by the left-hand axis. The animals in the black walnut silvopastures were almost a whole degree Fahrenheit cooler in the middle of the day than animals in the open pasture systems. And this was even in Blacksburg, which is in the mountains of Virginia, somewhat mild climate. The animals in the honey locust systems were somewhere in between the animals in the open systems and the black walnut systems. And this largely perhaps was because honey locust trees there on the right in this figure provide a little bit less shade than black walnut trees. There may be some other factors going on, but nevertheless, both trees had a modulating impact on ambient conditions. So this figure shows the regression or the relationship of the vaginal temperature of the sheep to ambient conditions there along the x-axis, or the temperature humidity index in this case. So you can see the slope of response is much steeper for the animals in the open pasture systems, that green figure, meaning that the animals respond more dramatically to increases in ambient conditions, whereas the trees in the black walnut and honey locust silvopastures had a modulating impact on that response. Also wanted to throw in this data. This is just a little bit of data that we collected in 2015. We had a parasite problem, so we were collecting fecals every month or so and analyzing those for fecal egg counts. And we noticed pretty substantial reductions in the number of parasite eggs that were shed by animals in the black walnut honey locust silvopastures compared to animals in the open pasture systems. We didn't have much of a parasite problem in 2016, so we didn't see that with the hair sheep. But this is some interesting preliminary data to consider that may also have an effect on animal performance It may be that the animals had an opportunity to self-medicate on the browse available in these silvopasture systems. There are some woody browse available from the stumps, as you can see in that picture, and there's condensed tannins in that browse that may have an inhibitory effect on parasites. Or it may be that because the animals were less stressed in terms of heat stress, that they had a better ability to fight off the parasites, whereas the animals in the open systems were more immunocompromised, if you will. And so some of the conclusions that we drew from this study in Blacksburg was that integrated silvopastures were more productive than the treeless pastures because the same animal output was realized plus whatever these trees provide. And also it was important to realize that the benefits that these trees provided to the livestock in terms of cooling and behavior led to more efficient animal gains in the silvopasture systems because these animals did better with less forage available to them, or did as well as with less forage available. So now I've moved about 3 hours east of Blacksburg. I've crossed over the Blue Ridge Mountains and down into the Piedmont region of Virginia. It's substantially hotter now. You can see that with this maroon dot here is where I'm at currently, and here's an aerial view of where I'm working. So quite a different climate and landform, and so it's very interesting to see how that climate plays an effect and the importance of these systems. Here's an aerial view of what our study site here looks like. It's a 40-acre replicated silvopasture site. It was largely started by Dr. Chris Teutsch. He's now a forage agronomist at the University of Kentucky, and he was instrumental in getting this all set up and running. Basically what he did, or had a logger do, is he thinned that belt of trees there in the middle. This was an existing woodlot, and he thinned it to about 30% of the existing basal area. On the west side of that white gravel road are largely hardwood trees, and then on the east side of that road are largely loblolly pine. On the northern and southern ends of that 40-acre parcel, everything was clear-cut, and of that, half was replanted back into pines and alleyways to simulate a new silvopasture planting. And then half of that was, or half of the clear cut was also converted to an open pasture to represent our control or conventional pasture system here in Virginia. Hopefully this shows you a little bit without being too blurry, but we're flying over the pine silvopasture there. There's the newly planted pines on the right, and then the open pasture, the control up ahead, and then towards the left is the hardwood silvopasture system. So hopefully that gives you a little idea of what the systems look like, at least from above, and how densely populated those trees are, what these conditions look like. So this is what we've seen in terms of forage characteristics. We've been doing this work for the past 2 summers here in Blackstone. It's hard not to be confusing. Blacksburg was in southwest Blackstone, now here in Nottoway County and south central Virginia. We've seen in the open pasture system, which is represented by that brown bar, a little bit more forage available, at least this was data from last year, compared to the silvopasture systems, which are represented by those increasing darkness of green bars. So the pine and hardwood silvopastures, those thinned silvopastures, had a little bit less forage. So similar to what we had seen in Missouri and also in Blacksburg, Virginia, with the lambs. There was little differences in terms of forage characteristics. In this case, the top bars are defined by the left-hand axis, total digestible nutrients, and then the lower set of bars is defined by the right-hand axis, percent protein. And across the treatments, there is little difference in the forage characteristics, but it'll be interesting to track how these differences might change over time. One of the biggest things we've seen, of course, is that it's much hotter here in Blackstone than it is in Blacksburg, Virginia. This was weather station data that was collected in the different treatments last summer. During 1 week, the temperatures were well over 105 degrees maximum temperatures for about a week. And the cooling effect is much less here in Virginia, doesn't get it, or less here in Blackstone, doesn't get as cool in the evening. And so heat stress can be a much more severe problem And in this case, we're working with cattle, which are not quite as heat resilient as sheep. And so we have seen some differences in terms of animal performance. This shows average daily gains from last year and the 3 months that we grazed those pastures. The animals in the open pasture systems in the first month of the study gained about 50% less weight per day than the animals in the silvopasture systems. Again, the brown represents the open pasture, and the dark green bars represent the silvopasture systems. Those distinctions largely blurred in the month of July, and then in October there was good gains. All the animals were gaining well, and not much difference, at least statistically, between those treatments. So it's interesting. It'll be interesting to track this over time and see how this changes with weather events, but certainly it does seem to make a big difference on animal productivity here in Southside Virginia. Also worked with a colleague from the Department of Animal Science to look at the heifer development on these silvopasture systems. So we took a reproductive tract score following the conclusion of the study last year. Basically, a higher score means that the heifers are more developed, so we saw some numerical differences, but largely no statistical differences. It'll be interesting to track this again over time to see if shade can have an impact on the sexual development of livestock, which can have, as we know, a big impact on the financial productivity of the farm. We're also lucky to do some interesting work with a tobacco agronomist here at the Southern Piedmont farm. He's got a drone and some pretty neat cameras, and so a graduate student, Austin Hayes, and my graduate student, Sarah Jane, have been doing some work flying over the pastures and actually measuring the body temperatures of these livestock, or at least the body temperature on their hide from the air. And so here are some powerful images that they've collected this summer. You can see an animal in the open, or the group of animals in the open pastures there in that top figure, obviously showing much more hotter temperatures on their back. And then those animals in the silvopastures enjoying the shade. You can see that cool outline of that pine tree on the ground at the shade that it's providing, and the subsequent lower body temperatures, or the heat load at least on their back, that they're exhibiting. Also, the animals in the open pastures, as you can see, are standing up, trying to dissipate heat, keeping air moving around their body. Whereas those animals in the silvopasture systems, at least 3 of them, 3 out of the 5, are lying down, obviously comfortable, even though this is a picture that was taken in the middle of the day. So pretty neat equipment now that can show some pretty powerful images about the effects of trees on livestock. Here's some of that data in numerical form. This is from one day that they did some flying, where they took measurements in the morning and then they took measurements in the evening. So the tan dots on the left are the measurements on the back of the animals that they took in the morning, and then the brown dots on the right are the measurements they took in the afternoon, about 2 p.m., I believe. And so some substantial differences in terms of the heat on the backs of these animals in the afternoon. Those animals in the hardwood silvopasture were much cooler than the animals in the open pasture system. So it's quite a big difference in terms of temperature. There's less of an effect in the pine silvopasture systems. This may be because the animals were a bit more active, or it may be that the pine trees themselves do not cool as well as hardwood trees. And so it will take some analysis to look a little closer at that, and hopefully we can take more measurements over time and figure out what's going on there. But really, as I mentioned, the end result is to create not only diverse landscapes that produce multiple products and can enhance ecosystem resiliency, but also can improve welfare of livestock and us as well as we work in these types of systems. I want to conclude this kind of synopsis of our work on animal performance with a figure from Dr. Rob Kallenbach at the University of Missouri. I strongly encourage you to watch this video on YouTube if you haven't already. The link is here on the slide. Basically, what they did is they compared converting to non-toxic tall fescue pastures, the effects of doing that compared to providing trees or shade to livestock in a silvopasture system during heat stress events. And what they found is, of course, that without shade and on toxic tall fescue, The cows in this case had very low calving percentages, which is a measure of their reproductive performance, how many cows had calves, 38 out of 100. The cows lost weight, and the weaning weights of those calves were very low. By providing shade to those livestock, even when they were still on toxic tall fescue, resulted in substantial improvements in calving percentages and benefits as well in terms of weight gains of the cows and the calves. There was also benefits when the animals were given non-toxic forage without shade, but the greatest benefits, of course, were to provide non-toxic tall fescue and shade to livestock through silvopastures, and this had impacts not just on reproductive performance, but also the weight gains of the cows and the calves. And so data such as these and such as ours show that trees can have a substantial impact on animal performance and should be considered in livestock production systems. And the real benefit, I believe, in silvopastures is not only do you get shade for livestock, but you also get additional products provided by the trees as well, thereby increasing the productivity of our land. So that's all I've got on animal welfare and performance, but I wanted to share a little bit about a short study that we did a couple winters ago in honor of the Savannah Institute's Honey Locust Pod Contest. If you're not familiar, check out their website and look at what they've got going on, searching for some big honey locust pods. But I'm excited about these pods, and we did some research that will hopefully pique people's curiosity and get them interested in thinking about pods. This happened in 2015. We had a large abundance of pods. These honey locust trees in Blacksburg are largely in a cyclical pattern of production, so they amp up production for about 3 years in a row, and then they stop producing in the fourth year before amping up again. And so we were reaching the end of that third year. There was a lot of pods on the trees, so we took the lambs off the pastures in August, fertilized with some nitrogen, allowed the tall fescue to stockpile, and we came back in November and December and started grazing to see what effect these pods had on sheep performance. So what we did was pretty similar to what we did in summer. We measured the forages, both the forage mass and also the nutrition, and then we used quadrats to measure the pod abundance on the ground. By this time, all the pods had fallen to the ground, and so we collected the pods off the ground to estimate pod yield per acre. And then, of course, we weighed the animals. This was about a 6-week study, and we weighed the animals every 2 weeks. Here's what we saw in terms of forage characteristics. The black walnut silvopastures there and the black bars yielded less forage than the honey locust, and the yellow and the open pastures in the green. So it mirrors pretty closely to what we see in the summertime, and also similar results in terms of forage nutrition. What was different, however, was the abundance of these pods. Quite a mass of pods were produced by these trees. These are on about a 40 by 40 foot spacing, and these millwood trees produced in that spacing about 4,300 pounds per acre of dry matter. Now, previous work has shown that these pods nutritionally are similar to whole-ear corn. So I've done a little bit of math here. The state average in Virginia of corn yield in Virginia in that year was 160 bushels per acre. That would be equivalent to, the units there should be pounds per acre, about 13,000 pounds per acre. And that essentially means that these trees on a 40 by 40 foot spacing produced 30% of the nutrients of conventionally monocropped corn, even while the forages underneath these trees produce the same amount of forage as forages in the open pasture system. And so in this case, if you're familiar with the land equivalency ratio concept, these silvopastures were about 30% more productive than open pastures and monocrop corn. You need about 130% more land to produce the same nutrients as these pastures have produced. And this was on pretty marginal sloping land as well, so pretty substantial the productivity of these pods. Unfortunately, the lambs did not actually eat the pods. They were naive. I was not expecting this because all of my experience previously had shown that animals relish the pods, cattle, goats, and sheep And so I was surprised when these sheep did not actually start to eat the pods until about 4 weeks into our short 6-week study. So that was rather unfortunate. So there's little difference in terms of animal performance in the first few weeks of the study. But then, as the animals started to eat the pods, as you can see in this picture, subsequent animal performance there in the 6th week was much better for the lambs and the honey locust systems, quite a bit more than the gains of lambs in the open pasture systems, which had essentially no change in weight during that past 2 weeks. And so this is a pretty interesting result and pretty exciting, and hopefully we can do some more work with these pods, but they do seem to have an impact on animal performance if the animals have learned to utilize them and consume them. So that's all I've got on the data that I've collected over these past few years. I want to recognize the vast number of people, both intellectual and collaborators that I've worked with, have the privilege of working with, who have been doing work on silvopasture for quite some time and have included me and welcomed me into this endeavor. Also the number of people who have helped with data and field and lab work, the veterinarians and the farmers who have provided not only animals for this research, but also land for some of the work that we're doing. And then also those that have funded this work. Thank you to the Savannah Institute for allowing me this opportunity to talk and present about some of what we've done. Please feel free, if you ever have any questions, shoot me an email. If you want to talk to anyone else, I work very closely with people in animal science, forestry, crop science. It really takes quite a team to work on these silvopasture systems, and so we've got quite a team assembled here that I'm very proud to be a part of. And with that, I'd be happy to take any questions as they come in or comments.
Wonderful, Gabriel. Thank you so much for that wealth of information. Such interesting research you're doing. So yes, I will enable the Q&A session. So we have Kelly Mulville here with a question. Okay, Kelly, your mic should be live.
Okay, I'm particularly interested in sources for the millwood variety of honey locust.
Yeah, good question. I wish somebody was growing them. I don't know of anybody who's growing them commercially for sale. I know that I've collected scion wood, and we have shipped it to people in Virginia, and they have grafted their own trees. If you're interested in doing that and you'd like some scion wood, email me, and we can figure out a way to perhaps get some to you. But at the moment, I do not know of anyone commercially producing available millwoods. And I don't know if the Savannah Institute knows any more about distributors in your area of either millwood or Calhoun, which is another famous variety of honey locust.
Okay, thank you.
I can certainly look into that and follow up with our producers and sources. Great, thank you for your question, Kelly. Gabriel, the thermal images were just fascinating. Are there plans, what sort of plans in the future to utilize that technology further are in the works? What ideas do you have?
Yeah, well, keep doing what we're doing, so get more measures over time and see what impact tree species has on the livestock, or at least in terms of cooling potential. So we'll keep doing what we're doing over time. Also, we'd like to correlate that to vaginal temperatures in the heifers. So if we can get a measure of the heat stress on the back of the animals, and then also the core temperature of these heifers, and to see to what level animals are able to cool themselves given the radiative heat load on their backs.
I'm also curious about availability of water and other sort of general cooling techniques that these animals might have access to, and how you're incorporating that into the data.
Yeah, okay. All of our treatments in these experiments are treated the same, and so they all have access to, well, in the case of the sheep, excuse me, the sheep work, those were out of open tubs. So they all had access to water in the same general vicinity of their paddocks. They couldn't get in the water, they could only drink it. though they may have tried at least to dip their, I don't know how much they tried to dip their head in or not. And then in the case of the cattle in Blackstone, they have ball waterers in that's centrally located in each paddock, and then we rotationally stock those pastures around those ball waters. So you can kind of see in the background of this image that I think we're currently on, you can see where those waters are located. So in all of our studies, we haven't included water as a confounding factor, if you will. That certainly is an ability, or the availability of water, but also the type of water available to livestock can have an impact on their heat stress. We've kind of come at it from let's see what the effect of shade is first, and then see how perhaps later different types of water sources, or even the ability of, in some cases, water getting into surface waters, how does that have an impact on their body temperatures. One thing that's interesting, there is some data in the literature to indicate that the provision of shade away from waterways, such as impaired streams or creeks where livestock would normally spend a lot of time, actually reduces the amount of time that they spend in those waterways. And so providing shade to livestock can actually be somewhat of an effective way, if we don't have a stream exclusion fence, to keep them out of water. To some extent, it may not be the best choice, but that may be an option.
Kelly, you should be back on if you've got another.
Okay. Yes. So I'm actually on the West Coast. I'm in Central California, and I'm wondering if you might have any suggestions of tree species to use out here, or know of some people out this way that I can talk to. Some ideas that I have are honey locust, obviously, and black locust also is adaptable to this region, and is growing kind of ferally on the ranch. But I'm also looking at things like using potentially mulberry, carob, walnuts, Persian walnuts or English walnuts, and some other things like pomegranates, which probably won't provide much shade. But anyway, any other species that you have had success with back east, or that you might suggest for us on the West Coast?
Yeah, that's a great question. I wish the whole team was here to talk about this and punt it around. We've worked with many different varieties of trees. Of course, these in the case of thinning forests, we're kind of stuck with what was initially there. So in that case, it was largely red and white oak and some hickory, and then also loblolly pine, which is our kind of predominant commercial pine here in Southside Virginia. We've also considered other species. When you plant in the pastures, you have a little more opportunity. That sounds, I guess, kind of like what you're looking at doing. So certainly honey locust and black locust we've considered. There's been some worry from producers and other people about the spread of those species. What I've noticed is that in a managed pasture, black locust and honey locust are grazed and kept down. So in our case, we never saw any thorns of appreciable size in honey locust pastures, because the sheep would graze them preferentially. That was the first thing that they would graze when we moved into a new paddock, would be any residual honey locust growth. So that's something to keep in mind for both honey locust and black locust. Both of them fit well. They have a good morphology, and the leaf structure allows in some substantial light for the forages growing underneath the trees. Walnuts, I guess, would be similar in terms of the composition of the leaves and some of the chemicals that are produced and the products that are provided by the trees. So I think that would be a good fit as well. I'm not sure, I haven't done any work, but I know here at least, but I know pecans have been more of a choice in the lower Midwest in silvopasture systems. I'm not sure what types of pines would do well in your area. but in terms of, for us anyway, they're desirable because of their quick rotation times. And they're also very cheap, and so we can plant large amounts of them, and they'll grow quite quickly and allow us to reintroduce cattle faster into a pasture. I'm trying to think of other things. We've planted oaks, red and white oaks, into pastures. Probably a little harder to deal with. They've got a little bit of a denser shade, and the leaves don't break down as well as the locust leaves might break down. So you have some litter effects. I guess you could think about some other fruit trees, though I have less experience with that as well. Yeah, I like your suggestions. Mulberry, perhaps. I think in that case, or at least from what I'm familiar of it, it's palatable to livestock, and so balancing both the protection of the desired tree, but also trying to reduce its spread, since I think it does spread pretty rapidly with good grazing management, may be important.
I'll also put in a plug for our perennialmap.org site and sort of ability to connect with perennial agriculture farmers all over the country. So that might be a good source for you to find other California folks or Western United States farmers and collaborate and share ideas through that source. That's linked on our website, of course.
And if you find something that works and you heard me talk about it, then send me an email and let me know. I'd love to hear more perspectives about what people are trying and the species that they're using.
Okay, I'll do that.
Great. Any other questions from the audience? And if not, any final words, Gabriel?
No, thank you. I appreciate the opportunity. Hope you all enjoyed it. Again, if you have any feedback, just send me an email. We'd love to talk more.